But we have another speaker now, which is, thank you. So we have Orly Lewis, who is going to be presenting Re-animating Greco-Roman anatomy through machine learning and 3D modeling. So Orly Lewis is a senior lecturer at the classics department at the Hebrew University of Jerusalem. Also co-presenting with Premshay Hermon, who's an MA student.
No, it's okay. Yeah.
Are you using your own?
No, we're just using it for notes.
Okay, no, that's fine. Are you have a stick for the presentation?
It's on
It's
here.
on.
Yeah.
We will stop share and then reshare.
This one? Or do I?
Open up the.
Yeah,
PowerPoint
open up it first. So just press the X. Just go out and open up yours. We do have a pointer here, but it might be.
Seems to be out of battery, I'm afraid.
Okay. So yeah.
Okay, that's great. Thank you.
Yeah, okay, so just maybe just to put things in context. So good morning, everyone. Thank you very much for the opportunity to talk here and for the organization of this wonderful conference. It's really fascinating. So we'll be presenting the work of the ATLOMY lab. I'll explain that in a moment. So I'm Orly, I'm the PI, and Premshay is both our product manager and in charge of our data science. And let me jump in. Okay, so the pointer doesn't work, but yeah, okay. So we are in Athens, and it's the 4th century BC, and Aristotle is teaching. And the topic of the class today is the heart and the human heart. So this is the human heart. We are looking at it from the front. So this is the left side of the human body, and this is the right side of the human body. And the heart is fairly round in shape, strongulatorum, except for its tip, which is narrows to a point, pointing downwards. And the heart has 3 coeliae, 3 cavities. So a large one on the right side, a small one on the left side, and a medium-sized one in the middle. Inside these cavities, we find neura, tendons, which, sorry, we forgot the most important thing. With technology, you can see quite a bit. You cannot see the tendons, the neura here, but you can see quite a lot of things. You can pass it around in the printed model. And the heart, of course, is connected to the rest of the body through vessels, but that will have to wait for the next anatomy lesson. What you saw here, this model is one of the main outcomes, is an outcome of the research in ATLOMY, a 3D model of the heart according to how Aristotle in the 4th century BC understood it. ATLOMY is a research lab situated in the classics department at the Hebrew University of Jerusalem. We are studying and researching the history of Greco-Roman medicine and developing digital interfaces and research methods. So the interface in which we view this model is another outcome of our research that is a digital interactive atlas of Greek and Roman anatomy. And we developed on computer and are still developing further this atlas. We've developed it in order to make the 3D models that we are designing accessible to scholars and accessible to them in a transparent manner, and with all the scholarly tools and means that they require in their research. And in order through this to allow scholars to better understand anatomical references and anatomical text, or anatomical references to terminology in the text they're reading, and in that manner better understand the ancient text they're reading. Now, when we talk about anatomy in Greek and Roman texts, we need to remember that we have, of course, really dozens of dedicated anatomical writings. At the same time, we also have anatomy is very present in Greco-Roman literature, in terminology, in short descriptions, in metaphors, and long descriptions, which appear not only in medical texts, but also throughout the Greek and Roman literature, in poetry, tragedy, philosophical, historiographical texts, and so forth. And when we talk about Greco-Roman anatomy, we actually should be talking about anatomies in the plural, because each author in antiquity who is researching the body and opening it up and looking at it is understanding the inside of the body in his particular way, and is using his own terminology to describe this anatomy. Sometimes it's similar to other people and other writers in antiquity. Sometimes it's a bit different. So what I showed you just before was an example of such an understanding of the heart according, as I said, to Aristotle, which is described in his work, one of his major zoological works, Research on Animals, the Historia Animalium, in passages which are much debated and discussed in scholarship. Now, besides viewing the model, you can also reach one of what we call our lemma pages. Here you can see the lemma page of koilia, the Greek term koilia, which means cavity, but with many different senses and contexts in our texts. You can read them briefly about the term. You can see in what physiological systems it appears, in which models in our atlas it appears, synonyms, and read a long analysis of the history of the term in the different authors and in different periods. And you can see a list of references, both for the bibliography and as in the form of a concordance. Now you can reach these lemma pages either from models by clicking on parts and then seeing the term and deciding to go further and to read in more detail, or by searching from any place in the atlas. You can search in English, ancient Greek, Latin, Arabic, or the later language we'll be adding. So here, if we search for cavity, you'll get the results which are particular to what you are searching or related. You can filter and sort the results according to your own particular needs and requirements. In addition, you can also learn, you can also visit the model pages by clicking on the info icon. Here you are seeing the model page of the model on Aristotle's gastrointestinal system, well, gastrointestinal system according to Aristotle. You can see in such a model page a list of parts, the ideas informing this ancient model, and the list of the sources and interpretive decisions that we made in creating this model, how certain we are, various questions which are still open, interpretive comments, manuscript issues, and so forth. So really giving you all those footnotes that you might have been missing when you were looking at the 3D visual material. So these features that you've seen, searching the term, viewing, learning about the model, digging deeper into the model and the inner parts, all these are results of our user research and product thinking, which is really allowing us tailor our interface, not only our content, but also our interface for the requirements and needs of different scholars, ranging from classics to modern medicine, students of modern medicine. We also have the access is online, it's open access, web-based, anyone can easily access it. And we have this in mind also in order with looking at the general public and having them in mind, and adapting this also for the general viewer who is just interested in this and not necessarily in all the different scholarly aspects. In order to do all of this, we had to really shift the paradigm and to shift the way we were thinking about ancient texts and interpreting our ancient medical texts. So what I'm going to do now for a few minutes before passing on to Premshay is to take you through the method we've developed, which combines philological, experimental, and visual analysis of the ancient texts. Then Premshay will zoom into our data science work, and we'll end with a brief explanation of our vision forward and a little treat at the end. Pressing the wrong computer. So we begin with the text here in ancient Greek, sometimes in Latin, sometimes in classical Arabic, because some of our texts are not extant in Greek, but have been only in the medieval translation into Arabic from the 9th century. And we begin by translating it into English. Translation is already an interpretation, and it also allows the discussion in the team. Not everyone is a classicist or has all languages. We do this preliminary translation already by using traditional philological methods, as classicists have been using for centuries, but also computational methods, on which Premshay will also discuss. And once we have this preliminary English translation, we move to the anatomical deciphering and the experimental analysis, together with the anatomists on our team, both from the veterinary field and human medical field. And so these people are those, they know our work very intimately, they're part of the core team, work with us on a daily basis. And they're the ones who can really bridge the gaps for us between us, the historians, the classicists, and the ancient physicians. They know from their work the inner body in the living and the dead body, and can really help us better understand what's going on in the text. And we do this not just by looking at books together and discussing, but also via dissections in the lab. And the ancient text is what's guiding our dissections here, okay? And the research questions that we have come into this dissection, and there's a lot going on in the lab. We are scanning in 3D, we're taking notes of our insights, both recording and typing them up so as not to miss anything. But at the same time that this is, the text is informing the dissection and this whole discussion and work with the anatomists is what's making us understand the text better. And therefore we can reach an enhanced translation and understanding of the text. And with this, we can move together with our 3D illustrators to the 3D modeling, that is creating a visual 3D digital visual interpretation and visual and representation of the anatomical details in our text. Now, this process is an iterative joint process where it's not that we just send the guidelines to the illustrator and he returns with a model, but we're talking constantly. And this process is a crucial part of our research and interpretation. This is what we're calling the visual analysis of the text, because only when coming to visualize this, especially in 3D, do we realize what we have missed in the text and things that we didn't even realize that we were not understanding, forcing us to be much more concrete, much more careful and nuanced in our interpretation and our reading than if we were just translating or writing an article. Once we have the model, we can embed it in the atlas and make it available with all the tools we have. As we saw, it's not just a visual interface, but also at its basis, it's really a lexicon, visual and textual lexicon of ancient anatomical terms, so ancient anatomical lemmata.
So at the base of our methodology, we will spend a few minutes talking about the methodology that we use in our research, and of course, how we also utilize machine learning and artificial intelligence. So at the base of our methodology lies the lemmata, which is a word with a unique meaning that we find interesting, specifically here anatomical. We talked about anatomical parts. Since the lemma can appear in different ways across the text or even within the same text, we need to gather all of its occurrences and analyze them in context. So our process includes three main steps. The first is annotating a block of texts. We'll go through this in a minute, but annotating and aggregating and pouring all that data into a cluster of data tables, of relational data tables, analyzing them in different ways, and eventually taking it into the online database, which is the atlas, which is accessible to all. So a process starts with entering a text into the annotation program. We use Inception, which is an annotation platform for semantic annotation tasks. We tag each word with a category type, each word that we are interested in with a category type. So for example, body part, the query is a body part. The list is the annotation, the tags are from a predefined list that we decided on, and it includes different categories that we decided on. We then assign a lemma for each word and continue to do so to the entire text, not just the words that we are interested in. We also tag each word with each part of speech and its dependency. We will show why in a minute. We also use the opportunity to label bibliographical details, from book name and author to page, section, and line number. This saves us time later on when we want to prepare this for either a publication or for the online database. So basically, we have all the references of every word ready. Oh, yeah, it's good. So what we do here is actually convert unstructured text to structured data. So our data structure relies on relational tables. These are a cluster of tables that make the entire information accessible from every other table. We have complete transparency and complete accessibility of all the data in one structure. The text decomposition is shown that we showed before ends up here in this large table with subtables, where it is used in different ways. So one way is for the researchers to review, analyze, and extract insights. They add these insights to the tables, which are then used by the 3D artists to correctly model the anatomical parts. Another way is a basis for continuous knowledge development. So the data structure provides transparency and accessibility. I mentioned that, but the way it does it is that every researcher that goes in can see everything and search and filter for everything. And it's not just the technical details, but also the interpretations and every description and every comment that anyone else on the team wrote. So we keep iterating on this information and making the case stronger or polemic, adding references to the same word, to the same lemma. This has made this database a really strong information center for us, but we don't keep it as an internal center. The information that you see here and much more proceeds down the line and becomes the core of the online database, which is the atlas, which is and the lexicon, which is open to all. It goes through an automation process that it is in an automation process, but it converts into the structured lexicon that we have on our database over there. It is a bit different from the one we use here, but it doesn't matter to the people using it. So each lexical value includes features such as the translation, transliteration, the systems and function that it is in, the treaties, the short description, the long description. If it has models, then the models, and also two forms of references. One is the abbreviated reference, and another is it's a concordance of sort. We heard from scholars that they are looking for ways to speed up the process of finding the references, of looking up the references. So as much as we can take in consideration copyrights, then we have our system here where we show where exactly in the text you will find it. What are the 2 words before, 2 words after? It can be 3 words, 5 words, 1 word, whatever you want, but basically the context of the word. So you can see everything from within here and you don't have to run and look for the book anywhere. So our method has a few advantages. One is speed. We found that the work on each lemma is highly accelerated. The second advantage is the speed and precision of syntactical and morphological analyses with these tools, which would otherwise take a lot more effort and a lot more expertise from people in linguistics. Moreover, the iterative process in which we work requires domain experts to look at texts a bit differently. Orly mentioned it earlier, and to make precise decisions. The fact that they are also being reviewed in real time by their peers or being commented on creates a very lively discussion and makes everything much more precise and consensual. And again, everything is on the data tables. It's always been, it can be reviewed even 2 years later when a new text is added and has the same words or lemmas, so everything aggregates automatically. The method we propose is not limited to anatomy or to ancient Greek. It can be used in other domains and for other languages, reaping the benefits portrayed above. And I'm certainly pitching to the choir here. We are more than happy to work with each of you on use cases for the methodology as well as for the online platform if you see it as something you can use. So the whole process works really well when it's manual, but we can still do much better. So we set to explore how we can create an automated research assistant. Sorry for anyone who was ever a research assistant. Something that will scan, analyze, and retrieve the information per the scholar's needs. We do it with machine learning. It's no coincidence that we use a machine-assisted annotation platform like Inception that we showed. We have been working to develop expert models, machine learning models, to support our work. Specifically, we're building models that can perform tasks such as named entity recognition, lemmatization, parts of speech tagging, and morphology understanding. Our database is also a data set for training models. We explore various tools and architectures, but we mostly work with Spacey, which is an open source library for advanced natural language processing tasks. It's built around the idea of a pipeline. Okay? It's a set of models, each is an expert on their own, and they work as a pipeline where you can perform various tasks per your needs. So in this snippet from our internal code or test code, we asked them, we threw in a corpus, and we asked to find any word that, I mean, if there's a body part within the sentence, then bring up the sentence. And if there's the koilia as the lemma of any word there, if koilia isn't there in any inflection, bring it up. So on one text or one corpus, it found this row where koilia is there, and of course it's tagged as a body part already. Another text that found different body parts, where we ask different body parts, not necessarily koilia. So you can see everything, and it shows us what it found on the text by itself, right? It's, again, machine learning, it's not us. That way we can just tell it what we're looking for, and it will bring all the relevant references. We use our trained models to recommend annotations back in Inception when we work there and annotate, as I mentioned before. This just reduces the time spent by the team on annotations, and it also serves as a real-world evaluation of the model's accuracy. Okay, I will remind you that our goal is to bring it as a general tool, just like we did with the Atlas. And it should be used by our scholars and by other people without being in code or training on annotating. So we keep enlarging the data set in order for it to understand Greek well enough perform these tasks without any more training or substantial training. So back to the advantages. We see an acceleration in the work on each text when we use a machine learning based recommender. It also reduces the effort needed to analyze syntactical and morphological features. In our iterative process, the information is taught to language models, which become better at understanding the language and perform their NLP tasks. After we train and deploy the models, they help analyze the texts and gain insights even without having a domain expert in the room or in the project, for that matter. The technology amplifies the ability to replicate the method for use in other domains and languages. So hopefully by the time we are finished with the code, with the model itself, then we will be able to replicate it for other fields, not just the categories that we are, but basically you can annotate a small sample, give it a sample of another category or another use case that you need, and you will be able to train it really, really fast and do the work well, again, without you needing to invest or anyone needing to invest whatever we need to invest for developing models.
Okay, so just to say a few words about what we're looking forward to and thinking of. So first of all, we are working on using machine learning to help us write the lemmata, which is of course taking a long time. We want to add into the atlas, into the tools, you have the means to compare between different models. As I said, we would have different anatomies already in Greek and Roman, so compare the heart according to Aristotle to that of Galen, and also then compare to modern times if you would like. But also looking ahead to going beyond Greece and Rome. So we have already some interest from Near Eastern ancient anatomy and other periods and cultures. So to bring that in to the atlas, you make it more than just Greco-Roman anatomy, but really an historical atlas of anatomy, and then also use our comparison tools to compare between cultures and periods. But also going beyond anatomy, we have already integrated animations of the physiology into the atlas. So going beyond anatomy to other parts of medicine, diagnostics, physiology, therapeutics, and so forth. And of course, the whole idea is that this is a kind of model of anything that requires both visual and textual lexical. Could be, we could share our code to create this kind of atlas if it's not something which is suitable to be in part of our atlas. But that's, as I said, broadly defined. But also integrating VR and AR, so virtual and augmented reality capabilities into the atlas for viewing additional content. And finally, something, do you want to explain the thought?
Yeah, on one of my talks with Bing Chat about the subject and seeing how well he does to summarize the lemma. So after a while, I asked him to write a poem about the ancient medicine and the ancient Greek physicians. And this is what he gave, just his creativity, or her, or it. They wrote of bones and blood and breath, of life and death and health and disease. They observed and measured and dissected, and recorded their findings in verse and prose. They gave us names for parts and functions, for organs and systems and structures. They laid the foundations for modern science and inspired the generations of scholars. They left behind a treasure of texts that span centuries and cultures, but time has taken its toll on them and left us with gaps and fractures. We seek to restore and annotate them with machine learning and natural language processing. We hope to uncover their secrets and meanings and honor their legacy and wisdom. Thank you very much.
Thank you very much.
Thank you for a great talk. Do we have any questions? Yes.
Yes, thank you so much. It's absolutely fascinating, and I will love to use that. I have one question: is would you also consider to look at texts like Plato's Timaeus, for example, where he at some point puts much effort into describing the breathing system and the lungs, but nobody really understands what he tries to say because he compares it to a fish trap, and there are a lot of interpretation. How would you try to
So it's on the list. I mean, so it's on the big list insofar. So the research is currently funded by the ERC, the European Research Council grant. So also focused very much on the key corpora we have, which give us very good information we can work with: Aristotle, Hippocratic and Hellenistic texts, and Aristotle and Galen, sorry, and then we would like to go beyond that, and especially to the texts, as you say, which are a bit more difficult to really just create a model as we would usually see it, and there's a lot of sort of interpretive and metaphorical issues that need to be overlaid. And we already have, part of our research is already looking at the metaphors used to explain anatomy and physiology, and thinking very much about how to incorporate that into the atlas. So the thing is that really the anatomy, the basics had to still be done, and therefore through this and through the method that we are developing, we can then better approach the more, I mean, this is complicated enough, but the more complicated and challenging, sort of less straightforward, let's put it that way, anatomical content.
And would you consider to come up with models like, because I would love to see that fish trap, for example, but would you do that, or is it?
Yeah, that's part of, I mean, so we have lots of sort of comparisons to spider webs, to funnels, to household material items. So, I mean, now we are working on the first text, which includes the valves of the heart, and that's also described in terms of the spider web. So how to bring that into the visual and not only into the textual, into the model page explaining the parts.
Okay, thank you so much.
Any other questions for the speakers? Yes.
What do you think about, you said something a bit more complicated, so what about Ezekiel's descriptions of angels with eyes and wings and that kind of thing? Or like I work on Jewish magic bowls from the late antiquity. They talk about the description of demons with chicken's feet, and even Talmudic stuff as well.
So definitely, I mean, anything, I mean, we need the scholars to do that. So that's also the issue of one of my closest colleagues works on the magical bowl, so I know them quite well, and also some of the Talmud or the biblical stuff. But we need the people who really do know these texts, because they need to work. They need to come and work with the interpretation of the text, and we give them the method, the tools, the facilities, and the platform to develop it. But absolutely, we've been working fairly internally. We're exactly halfway, and now's the time where we are looking to, we have something that we can offer, which is very concrete, and we're looking for these kinds of collaborations also because I'm sure they can be improved insofar as what others, I mean, it's very much about other scholars and not just our own research. So definitely.
Yes.
So following up on that, in terms of the workflow, are things like the anatomical images something that you have to create from scratch, or do you import those from other work that's already been done? So
the 3D models that we show,
yeah,
absolutely, we work from scratch. We have experienced professional 3D modelers who work with a different 3D modeling software. We are experimenting with various ways of using CT scans as a basis for the models and overlaying on that. But I mean, they're doing the modeling from scratch. We're not using, I mean, the whole idea is that we model it really according to our instructions from the text. We do have the vision of
we do dream of our moonshot is 3D, I mean, text to 3D.
right,
Basically, which for this specific use case, I mean, it's so niche that we have very good ground truth in order to train a model to do that. But the technology as a whole is not there yet, and our research, as I said, one of the issues in this space where we are all at is that there are no good enough language models for the ancient languages. It's not like the most of the modern languages again, we know that not all Arabic and Hebrew, for example, are languages that modern Hebrew and modern Arabic, we don't have good enough language models. So it's still an issue, but definitely for the ancient languages. Once we have that, we can move along to more interesting and complicated stuff, but the basic is still very much needs to be deciphered by the community.
Any other questions, speakers? Yes, Lindsay.
I wondered if you had any interactions with sort of the sort of public and impact side of who you want to use it. Are you getting any medical students or doctors who just love it, or?
So as Orly mentioned, I'm the product manager. So and our entire approach is product oriented, not just scholar or academic. So we have a tester base, which goes through interviews, which we started from when it was just vision and all the way to beta, alpha, beta, etc., which we interview and test on and hear about the features that they want, what's working, what's not working. And of course, we now are expanding that circle towards the next phase. So we get the personal communication, the personal results. It's supported. It's not like it's going to be used by hundreds of thousands of people. We don't think it will be that way, but we want what we have and what we're doing to be good enough both for users and also as a platform for others to make their own lexicon or others atlas. And this is part of the next step. And then we need, of course, that kind of feedback behind the stage, behind the curtain.
And we can add maybe about particularly the medical students. So we are in touch. I mean, so first of all, we have these kind of people on our team, but they're biased, obviously. They love it. But we are in touch with the medical schools, especially what interests them is actually the lexical entries, because they encounter the same terms, and they're interested more or less, but it helps them to have the etymology. So we are working to tell us, if you're going to teach these kind of terms, we can expedite specifically on these lemmata, or give you something. And also, I mean, part of the whole vision, I mean, so you have these kind of 3D atlases for modern medicine. So students and medical professionals know, it speaks in their language. And in most, many medical journal articles have a sort of brief history part, okay, liver problems, and then, they don't have the tools. They can't really go to our text. So this can really speak in their language and allow to really bridge the gap to them of saying, okay, these are texts, here, this is what you should know, and that's enough in a way you can interact with it. But they're definitely part of the wider circle of users.
Yeah, by the way, they're very much interested in what HUJI shown us, because the etymology is so important to understand what the word means, where did it come from, so I can remember it and not just, recite Latin or Greek words when I'm a doctor.